Hi everyone, my name is Winona Lam and today I'm going to share my experience teaching grade 1 using aquaponics. Aquaponics is essentially a combination of fish farming and soilless plant cultivation. Without further ado, let's explore the science of aquaponics and how it might be applicable to your personal journey towards sustainability or teaching. Aquaponics is a term coined in the 1970s. It has its origins in ancient agricultural practices. For instance, the Maya and Aztec civilization utilized a unique method called chinampas, where they cultivated crops on special islands. These islands were constructed using nutrient-rich mud and water from nearby canals. The canals not only provided water for irrigation, but also served as a source of nutrient to nourish the plants. Another ancient way to aquaponics started in South China, Thailand, and Indonesia. They raised fish such as loaches, eels, carps, and snails along with the rice. Additionally, the ancient Chinese practiced an integrated aquaculture system which involved the harmonious coexistence of finfish, catfish, ducks, and plants. Some of these practices can still be found today. The ducks plays a crucial role in controlling weeds and providing natural fertilizer, eliminating the need for pesticides and other chemicals. Aquaponics is a self-sustaining system that mimics a natural ecosystem. The nitrogen cycle gives an insight as to why the system is sustainable. First, fish produces waste, ammonia, through their excretion. Then, naturally occurring beneficial bacteria in the water convert the ammonia into nitrites and then into nitrates, which are nutrients for plants. The plants derive benefits from the nitrates while also serving as habitats and hiding spots for the fish. In turn, the plants help maintain a chemically balanced and purified aquatic environment that benefit the fish. Learning with aquaponics would allow students to comprehend the connection between plants, animals, and the environment. Through this lens, we provide an avenue for students to connect with indigenous values and knowledge systems, fostering a deeper understanding of the natural world and our place within it. Some of you may be familiar with Maria Montessori's cosmic education, which describes the role of education as comprehensive, holistic, and purposeful, and teaches the interconnectedness of all things. Montessori's concept regarding pets in the classroom teaches students valuable lessons about responsibility, empathy, and treating living beings with respect. Aquaponics provided my students with valuable hands-on learning opportunities to observe and study animal behaviors, needs, and habitats. I believe that true learning happens when we make connection across subjects, fostering a more holistic approach to education. The revision made to the science curriculum in British Columbia in 2013 aimed to place a stronger emphasis on teaching ecology and environmental learning. This highlights the significance of understanding our natural world. Through a cross-curricular approach and through observation, I hope that my students can eventually develop a habit of taking inspiration from nature and paying attention to the interconnection between all beings. My other goal was to make known on social media to other educators about the benefit of aquaponics. I have created 2 videos, one about my aquaponics journey with my grade 1 students that I will share with you momentarily, and another that is on my professional Instagram page. Both videos can be accessed on YouTube. Here's a video about my aquaponics learning journey with my grade 1 class. I first introduced the life cycle of plants and guppies to my students. To make it more interactive, we engage in hands-on activities, starting with the germination of Swiss chard and lettuce seeds. Once the sprout developed strong roots, we carefully transferred them into our growing trays. Throughout the process, students actively participated in brainstorming, problem-solving, and constructing the aquaponics system. We also involved the wider school community in our project. The custodian contributed lemongrass cuttings and lettuce seedling, and our buddy class visited to observe the system. Additionally, the vice principal often brought in students she was working with to view the fish and the setup. During student-led conferences, family actively discussed about the plants and the fish. As part of the learning experience, we looked into the concept of light as an energy source and its significance for a living organism. We also explored the different materials used in the setup, such as opaque, transparent, and translucent materials, and discussed their impact on the plants and the fish. However, the journey also presented its fair share of challenges. One of the primary hurdles I encountered was the initial setup of the aquaponics system. I faced difficulties in finding a suitable method to support plants above water. Initially, I explored the option of using floating sponges or mesh net cups at home. However, after carefully considering and experimenting, I discovered that utilizing a growing tray filled with play balls proved to be the most sustainable and sturdy approach. To reinforce the trays, I employed a few binder clips, ensuring they were strong enough to support the weight of the growing tray. My objective was to prioritize affordability and accessibility of materials, making it easier for educators to incorporate the system into their classroom if they would like to replicate it. Additionally, I encountered two other issues along the way. First, I realized that yellow fluorescent light wasn't suitable for optimal plant growth due to its light spectrum. To address this, I made the decision to replace it with daylight-colored light bulb. Secondly, I had to tackle the problem of algae buildup within the system. To combat this, I introduced snails into the ecosystem, as they can effectively control algae growth. I would say the project was quite successful. Firstly, students consistently demonstrated a high level of engagement and enthusiasm throughout the 3-month duration of the project. They actively participated in setting up, maintaining the aquaponics system, as well as monitoring the growth of the plants and the fish. This sustained interest indicates that the project resonated with them and captured their attention. Through this experience, I learned the amazing impact of hands-on project-based learning, especially in teaching complex concepts like the nitrogen cycle and light energy. I also discovered the importance of being flexible and adaptable when using innovative teaching methods. This experience also highlighted the significance of teaching sustainability sustainably and how I can empower students to become responsible global citizens through cultivating a love for nature. On this slide, I have included a few themes and topics from BCK to 7 curriculum that can be explored through aquaponics. Incorporating aquaponics in any curriculum offers interdisciplinary connections and hands-on learning experiences for students of all grade levels. They gain insights into the life cycle of plants, fish, beneficial bacteria within the system, exploring the intricate interdependence in ecosystems. Aquaponics teaches about the plant's needs, the water cycle, sustainable agriculture, and responsible food production by minimizing water usage and eliminating synthetic fertilizers and pesticides. Furthermore, aquaponics encourages measurement and data analysis skills as students track water quality parameters and identify patterns and relationships. It allows for exploration of food production, healthy eating, and the connection between food choices and overall well-being. Students can investigate how aquaponics contributes to local food production, promotes sustainable farming practices, and reduces reliance on imported produce. They can also explore indigenous knowledge and compare and contrast to historical farming techniques. Overall, aquaponics provides a comprehensive educational experience that fosters understanding of ecological systems, sustainable practices, and significance of food production. For my aquaponics setup, the simplicity and efficiency of the deep water culture method on the top right really eliminated many technical difficulties, making it easy to recreate and implement in future school years. Looking ahead, I recognize the possibility to explore other aquaponic techniques with my students in the future. To conclude, the project had a positive impact on my students as it provided them with a valuable opportunity to grasp scientific concepts through first-hand observation and experiential learning. By having students record their learning in their journal and participate in class and casual discussions, I was able to have evidence showcasing their growth over the last few months. As for the long-term impact, it remains to be fully explored. However, I'm optimistic that this experience will contribute to the students' understanding of the interconnectedness of natural systems and inspire them to continue to develop a keen sense of observation in nature. If you're looking to purchase aquaponics equipment, there are several companies that offers kits online, but they can be quite expensive. However, I managed to create my own setup with a limited budget for my classroom and achieved great results. If you are interested in purchasing equipment, here are a few companies that sell the necessary tools. Alternatively, you can also consider sourcing materials from platforms like Facebook Marketplace or local thrift stores to support sustainable practices, or support any hydroponics or aquaponics stores in your local community. So that's all I have for you today. Thank you for coming to my presentation.